Does that really happen?
Sure does. Thousands of experiments have been done since Einstein stated his postulate, and every one has shown time dilation and length contraction are real and really happen.
Back in 1971, 4 cesium atomic clocks were synchronized and flown on commercial planes that circled the Earth twice, and then compared to the reference clock at the U.S. Naval Observatory. Sure enough, the moving clocks differed from the reference clock by exactly the amount predicted by relativity. Let's look at it a little differently. Here's a graph of a car traveling due east at its maximum speed of 100 miles per hour. It is making no progress in the northward direction. All of its speed is going east. Now let's turn a little to the northeast. Even though the car is still doing 100 miles per hour, it is going less than 100 miles per hour in the east direction, because some of the speed is being used to go north as well. Space and time can be thought of in the same way. Everything in the universe is traveling through space and time at the speed of light, the maximum speed available. Picture time replacing east and space replacing north in the car example. If you were sitting still in space, not going north, you are traveling at the maximum speed through time, east. But if you start moving in space, north, your progress through time will slow down, since some of your speed has been diverted. The faster you go through space, the slower your progress through time. If you could travel at the speed of light in the space direction, you would make no progress in the time direction at all. Time would stand still, as it does for a beam of light. And if you could go faster than the speed of light, you could travel backwards in time. Remember, if different observers must always agree on the speed of light, then they must disagree on the components of speed. Time and distance. Time and distance both shorten for moving observers. These unusual effects of relativity, time dilation and length contraction, depend dramatically on your velocity. At everyday speeds, they are simply not noticeable. The fastest that humans have ever traveled is a few miles per second, a tiny, tiny fraction of the speed of which light travels, 186,000 miles per second. But in Einstein's universe, space and time are no longer absolute. There is no single time that exists for everyone in the universe, no distance in space that everyone can agree on. Space and time, like classical velocities, are only relative. Einstein preferred to think of a single entity, space-time, in which events and measurements took place. One observer might see two events as separated by a large distance, but occurring at almost the same point in time, while another observer views the same two events as occurring nearby in space, but far apart in time. While the individual space and time separations will be different, Einstein's equations allow the two observers to agree on the combined distance through space-time.